welcome to Eternal Easy Education. In this session, you are going to learn Chapter 2, Boolean Algebra. Content of this video is what is logical operations and what are the fundamental gates. This is the Chapter 2 and also the Part 2 Boolean Algebra. Boolean algebra is a mathematical discipline that is used for designing digital circuits in digital computer. As we know, computer is an electronic device and the content are stored in digital format, and it is also called a digital computer. So to store the content in 1-0 format, we need a basic thing, that is digital computers, that is designing the digital circuits. So to design the digital circuits, there is a base for that. So you are going to learn the fundamentals of the circuits. So what is a binary valued quantity? Every day we have to make logical decisions like Chennai is capital of India, then yes or no. That means the question of yes or no. So the answer will be yes or no. That means true or false. That is 1 or 0. Here it is treated as 1 or 0. The sentence which can be determined by true or false are called logical statements and are truth functions. Here the logical constant 1 is for true and 0 is for false. The logical variable or binary valued variables or binary variables, as these can store one of the two values, true or false. So the result will be true or false. Only one is possible. So here we are going to discuss about the logical operations. Boolean algebra makes use of variables and operations that are functions. The basic logical operations are and or not. So this is the very important thing, and or and not, and symbolically represented by dot plus, and the not can be represented by over bar. This is not slash, this over bar, I'll show it, or a single apostrophe. So these are the symbols for the operations. As we know, mathematical symbols are plus, minus, and for the multiplication, that is asterisk here. This is for multiplication. For writing the max, you will write a X symbol, right? Here there is no use of X symbol and it is replaced by the star symbol or the asterisk symbol. Here there are three operations, that means and, or, and not. And is represented by the dot symbol, and the or is represented by the plus symbol, and the not is represented by single apostrophe or over bar. And the truth table. You must know what is a truth table. A truth table represents all the possible values of logical variable or statements along with all possible results of given combination of truth values. That means for a and operation, for a or and a not operation, there will be a truth table. That means if the input is like that, compulsorily the output will be in that format. That is the truth table. You are going to learn now. We'll see one by one. First, we learned what is Boolean variables. That means the variable representing 1 or 0. 1 represents true, 0 represents false. Okay. Then the second point is logical operations. So logical operation means we are going to know about the and, or, and not operations. First one is AND operator. Operator in the sense it represents a symbol. What is the symbol here? Dot. It is similar to multiplication in ordinary algebra. So the dot going to represent a multiplication here. The AND operator combines two or more input variables so that the output is true only if all the inputs are true. So this is the working principle of an AND operator. That means if two or more input variables so that the output is true only if all the inputs are true. So it is going to have minimum 2 and maximum any number of input. So what will be the output? Here the output is only based on true or false. So we have to say whether the output will be true or false. What are the conditions? Based on which conditions the output will be true, and which conditions the output is going to be false. That means we have to have minimum 2 inputs. So we are starting the table with 2 input. A is the input and B is the input. Y is the output. So if the 2 inputs are false, 0, 0, then the net result is false. If one output is false and another output is true, then also the output is false. Here first input is true, second input is false, even though the net result is false. So whether it is a combination of 2 things are false or any one of the thing is false, the net result is false. Simply we can have one idea that in AND operator, if all the input is true, then net result is true. One line memory thing. What is the AND operator? The AND operator works when all the inputs are true, the net result is true. And it is represented as y equal to a dot b. So remember it, y equal to a dot b. When it will be true, as we can imagine as a multiplication table. 0 into 0, always 0. 0 into 1, that also 0. 1 into 0, that also going to be 0. Because we know any number multiplied with 0 is a 0 number, right? So if it is 1, the net result will be 1. Then what about OR operator? It's like a reverse thing. That means not in the reverse thing. Don't use the word reverse. I'll show you the difference between AND and OR. OR operator combines 2 or more input variables so that the output is true if at least one input is true. Okay, the truth table. Here one thing I want to say here is AND operator, if all the input is true, net result is true. Okay, here if all the input is false, net result is false, or else the result is 1. Simple. I'll repeat. AND operator, all the input is true, net result is true. Here all the input is false, then net result is false. What about next thing? If any one of the input is true, then net result is true. So you can have only this 2 points in your mind. AND operator, all input is true, net result true. OR operator, all outputs are false, net result is false. Then what about NOT operator? This is said to be reverse. That means if the input is either true or false and the output is always the opposite, that is the NOT operator inverts the input. If here we need only one input, so if minimum one input, so 0, then the result is 1. If it is 1, then the result is 0. So they will say it in reverse. So we learned 3 operators. One is the AND. AND means if all the input is true, net result is true. What about OR? If all the inputs are false, then net result is false. Then what about NOT? It reverses the input. If the input is true, output is false. If the input is false, then the output is true. Okay. Apart the 3, there is one more thing. Then that is NAND. What is NAND operator? N-A-N-D. It's the combination of NOT and AND. So NOT and together NAND. NAND is generated by inverting the output of AND operator. So inverting the output of AND operator. See here. First you think about the AND operator. 0, 0 means result is 0. So as it is in NAND, it should be reverse. So it is 1. If it is 0, 1, based on the AND operator, the result is 0. So it is 1. 1, 0. If it is an AND operator, it is also going to be 0. So reverse of 0 is 1. Here 1, 1. So result will be 1 if it is an AND operator. As it is a NAND operator, reverse it. So here, if all the inputs are true, net result is true, right? For AND operator. here opposite. If all the inputs are true, then net result is 0. That is NAND. So reverse of AND. Same, NOR. Not and the OR. So reverse of OR. What is the OR? If all the inputs are 0, net result is 0. That is OR. Okay. So what will be the NOR result? If all the inputs are 0, net result is 1. See here. If all the inputs are 0, net result is 1. So if you know, if you are very clear with AND, OR and NOT is very much easy. So nothing there to keep in memory. Only you should know what is AND and what is OR. AND, all the input is true, net result is true. What about OR? If all the outputs are false, then net result is false. So based on this, you can write the NAND and the NOR. NAND means reverse of AND. NOR means reverse of OR. So these are the logical operations of digital circuits or the digital. Here we have learnt only the basic thing. When this basic thing is going to be converted to circuits, then it is called as gates. So when the gates are formed, then the electronic circuits are formed. So the gate is the basic electronic circuit which operates on one or more signals to produce an output signal. So while we do the calculation part, for example, imagine your binary addition subtraction. If it is 0, 0 and the net result is 0. So the net result is going to be 0. These things are calculated by the logical gates. So if you are going to take electronics and communication engineering or electronics and electrical engineering, you will visually do the practical lab with the gates, and it will be very interesting to find out the answer. So there are three fundamental gates, namely AND, OR and NOT. So three fundamental gates are AND, OR and NOT. Other logical gates also available, that are NAND, NOR, XOR, XNOR. So these are called derived gates, which are derived from the fundamental gates. NAND and NOR are called universal gates. So it is an important 2-mark or 3-mark question. So three things you have learnt in this paragraph. One is, what are the fundamental gates? AND, OR, NOT. What are the other logical gates? NAND, NOR, XOR, XNOR. Among that, NAND and NOR are called universal gates. Okay, 3 points. Now, what about AND gate? Same procedure, but the thing, you should know this circuit. So this is the thing you have to learn when you are learning the gates. Same procedure, but you should remember memorize this logical symbols of AND gate. So one standing line and a curve, and these two are input and this is the output. The A dot B is represented as AB together. So we have to multiply A and B. So this is the logical symbol, and it can be written as A dot B, C equal to AB. And we will check the output. If it's AB, if it is 0, 0, then it is 0. As we know, this truth table, same truth table what you learnt in the AND operator is going to be the truth table of AND gate. Only thing you should know, this logical circuit. It is not a circuit, it is a symbol, because we are going to learn a circuit in different manner. So it is a symbol. Then what about OR gate? Same working principle of OR operator. The symbol you have to memorize. Logical symbol of OR gate. And it can be written as the result C equal to A plus B. Same truth table of OR gate. And the NOT gate. It will be very interesting to see the logical symbol of NOT gate. A triangle with the bubble. it is said to be a bubble, small circle. So A, see here, this is said to be the overlay bar. So in sometimes in the question paper it will come like a top line, or else it will come with a single apostrophe. So it should be treated as reverse. So the NOT gate means C equal to A bar. That means if A is 0, the result will be 1. If A is 1, the result will be 0. Same truth table of the NOT gate. NOT operator is the NOT operator and the NOT gate will have the same truth table. If it is an operator, no need to say about the logical symbol. But if it is a gate, you have to say about the logical symbol. That is the difference regarding the question and answer. So you have learned what is logical operator, what is Boolean operator. Boolean operator means nothing but which is going to give the result as true or false. That is said to be Boolean. So he is the person, an English mathematician George Boole. Based on his name only, we frame the scientist framed the name Boolean Algebra. He was born in the year 1815 to 1864. See that Boolean Algebra is developed in 18th century. Now we are in 21st century. Despite that, he thought himself highly advanced mathematics and different languages as a teenager without any assistance. So you should have self-motivation to learn many things. But if you want to shine in computer science, you should have some interest on mathematics also. So without mathematics, we cannot form the computer science logics. So that's all for this session, children. Thank you. Have a good day.